Elementary students. Today we're going to look at similarities and transformations. Earlier this year we had studied transformations. The transformations we had studied were rotation, where you were rotating at 90 degrees or rotating at 180 degrees, a reflection where the image was being crossed over the y-axis or the x-axis, and then a translation where you were moving that figure up or down or to the left or right. Today we're going to be looking at dilations, where it is enlarged or reduced. When you enlarge or reduce something, you're looking at a scale factor. The scale factor is the relationship of the ratio of a length of the image to the corresponding length of the pre-image. So you're going to take the scale factor, you're going to have the pre-image on the bottom, and then it's going to be the second image is going to be on the top. When you have a scale factor that's greater than 1, it's going to be an enlargement. That should make sense too. If something's getting bigger than that, would be an enlargement. If it's less than 1, if it's half the size, that's going to be a reduction. So let's take a look at our examples. Determine whether the dilation from A to B is an enlargement or a reduction. All right, so make note here, I already typed it in. The original is the darker figure, So I'm looking at my dark figure to my second figure. It's getting bigger, so I would call that an enlargement. Okay, the second thing they're asking you to do is to do the scale factor. So remember, it's the second image over the pre-image, and the pre-image is the original. Okay, and they're asking me to do it from A to B. So on my second one, I'm looking right here, I'm going to count them out. 1, 2, 3, 4. And on my pre-image or on my original, I'm getting 2. So that reduces to a half. And that's my scale factor, so I really should identify that, calling that SF. So my two answers, enlargement, and my scale factor is half. Okay, take a look at the second one. Or you're starting out with a figure. The darker figure, remember, is the original figure, and it's producing the lighter one, so it's getting smaller. So you call that a reduction. And so then now I need to find my scale factor. That's what they asked me to do next. I need to do A to B. So I went from here to here when I counted them. And again, I need to do my second figure over my pre-image. And so when I count, I get my pre-image. 1, 2, 3. Oopsie, this is my second figure, which is 3. And then I come up here, 1, 2, 3, 4, 5, 6. So I'm getting my scale factor to be a half. So half is my scale factor, and reduction would be my final answer. We only have one more problem, and that's at the bottom of the page. Graph the original figure and its dilation, dilated image, then verify that the dilation is a similarity transformation. So pause the video and take a minute and graph those points. All right, they want us to look at, I called A, B, C my original, and then D, E, F as my second one, because ABC is listed first. And so I need to verify this. And so I need to either verify it using my AA similarity, my side angle side similarity, or my SSS similarity. I don't know that I have two angles congruent, So this is not going to work, and I probably am never going to have two angles congruent when I'm graphing. I'm not going to be able to tell that unless I take my protractor. Side angle, side similarity, I could use that one. When I'm doing graphing ones, that's where I'm going to have a big triangle, and then I'm going to have a little triangle within it. And then that would be the big triangle, and the little triangle would have that angle in common. So then that's when you would use side angle, side similarity. And SSS similarity is when you don't have any angles, you have to find the lengths of all the sides. They don't have an angle in common, so I'm not going to be able to use the SAS, side angle, side similarity. So I'm going to have to show that all of my sides have the same ratio. And so when I go about doing that, I need to, and so when I go about doing that, I'm going to have to do my second over my original or my pre-image. And so I made my red be my original. That's the larger one. And my second one is actually the green one, the smaller one. So I'm looking here, I'm going to do the DF and AC, and I can count those out. I can count DF out, and I'm getting 3. And then I can count my AC out, and I get 6. And that reduces to a half. So my DF over AC gets me half. Okay, now I'm going to focus on my EF and my BC. So I'm going to do EF and my BC. I'm matching up corresponding parts. And my EF, I'm counting that out. 1, 2, 3, 4. And my BC, 1, 2, 3, 4, 5, 6, 7, 8. I'm getting half again. Okay, so now I gotta do my hypotenuses or the longer segment. And so I'm gonna have to do my DE and my AB. And I'm not gonna be able to count those out, so I'm gonna have to find those. This is what I'm gonna have to do here. So when I'm looking for my DE, I'm going to have to use Pythagorean theorem here. DE squared equals, okay, I'm counting that to be 3 squared, plus 1, 2, 3, 4 squared. So my DE squared is 9 and 16, that's 25. Square root of 25, DE is 5. Okay, so I'm going to come over here in my ratio, my DE is 5. Now I got to do AC, or AB, excuse me. This is not right, this is AB. So I'm finding AB, AB squared equals, I'm going to count these, 1, 2, 3, 4, 5, 6. That's 6 squared. I'm going to count these going up. 1, 2, 3, 4, 5, 6, 7, 8. So now I got my AB squared. I got 36, 64. Okay, that's 100. Square root of 100. 10. Okay, I was hoping for 10, right? Because I wanted to get half, and I'm getting half. So I've just shown that it is a similarity transformation. So now what I need to do is I need to write that triangle ABC similar to triangle DEF by, I'm using the SS similarity. So you have to have all that work, and then you also need that similarity statement which with your similarity test. You guys have an awesome evening, and I'll see you tomorrow in class.